Good morning, all y'all. Welcome, Michael. You're always consistently here, which is awesome. How's week 5 treating all you guys? Most of you guys, I think, are freshmen. How's physics? How about you non-freshmen? Morning, Squiddy. Physics notation is dumb. What is physics notation? Like vector notation? Like IJK? What do you mean by physics notation? That's good. It's always easier the second time you're learning something. That's true for pretty much everything, including programming. Do you have to take physics in high school in New York? Or is it, all the knots, yeah. You know. I like that. Morning, Schwartzmeyer. Okay, so, because when I took high school in Wisconsin, not New York, it was, you had to take biology, and then you had to take at least a semester of physics-related material and chemistry-related material, depending on how, not smart you were, but how, I don't know. My sister and I took a full year of chemistry the same year because she was behind. I don't know. But there were only certain requirements. So, I don't know. But in general, things are easier the second time you learn them. Notation is necessary but annoying. I remember when I took linear algebra in college, I got so annoyed with the formal language you needed to use. And so sometimes when you get into the formalities of physics, of math, it's kind of annoying in the fact that things need to be written exactly the same, where you're like, but I meant it to be that, or I meant it to be this. I don't know. I understand that can be very annoying. But you guys surviving? You getting through week 5? It's Wednesday already. Minecraft. Yeah. So same. There's lots of different things that introduce the ideas of programming depending on your background, depending on what you have access to. Weirdly enough, the number one indicator for passing and succeeding in an introduction to programming course is having previous programming experience, which seems kind of backwards. My goal is to not have that. My goal is to be able to teach you even if you don't have programming experience. But it is a different way of thinking, and a lot of times it's difficult. Specifically, programming is difficult for people who've never seen it before. I know I had no idea what programming was before I went to college. Yeah. But I mean, I like it now. I think I know it okay. I mean, it's hard to learn programming. It's hard to do something without some motivation behind it. Like, like Michael mentioned, he wanted to code his own Minecraft mod. Like, that's motivation behind learning how to do something. Whereas, like, if someone's just telling you, you should learn, but without, like, mentioning a project that you're interested in to do it, it's really hard to do anything, really, without some sort of motivation behind the scenes. Yeah, I mean, my husband and I are both engineers, and so I keep thinking, like, we can get our kids interested, or kid right now, however many we end up with, to be interested in things and to do projects. But if there's no motivation, then it's not gonna work. It's not gonna succeed. Okay, it is 11:30. Let's go ahead and get started. So here we go. On Monday, we started introducing the 5 functions that we're looking at this week. Input, display, fprintf, load, and save. We went through input, which anytime you see prompt the user, that is a indicator that you should use the input function. And there's 2 ways to use the input function. Oh no, I moved something. Okay, there's 2 ways to use the input function. So var equals input, and then in single quotes, you just enter in whatever text you want to use to prompt the user. So typically, single quotes, it should work fine with double quotes. Just note that single quotes and double quotes are 2 different things. They're both text, but they're treated slightly different behind the scenes. So you will see me type in single quotes, but double quotes should be fine. But if we are expecting numerical data, if we're expecting the user to enter in numbers, this works. That's it. If we're expecting text, it's very similar. We say whatever variable equals input, and then single quotes, and then we just add in that additional option where this S indicates that whatever the user enters in is going to be treated as text. Okay, so those are 2 ways to use input. We also talked about the display function, where disp is short for display, and we can print out just text. It would be disp, and then just type whatever text we want to print out in single quotes. There is an implicit new line character here, implicit \n, that indicates that it's going to print out the text followed by a new line, as if it pressed enter to start typing on the next line. If we want to print out text and data at the same time, we say disp, and then we have brackets, and we put in our text next to our variables, next to our text, whatever. Keep going, concatenating things together. Note if your variable contains numbers, then you want to do num to string. And that's how we use disp. I started to introduce fprintf. I'm just going to start from scratch today because we didn't really get that far. So in my problem that we went over on Monday, we prompted the user for some input, and then we displayed some results. And it looked like this in my code. So here I used the input, prompted the user, and then I displayed a bunch of stuff. So that it printed out like this. Remember, for the display function, we don't have that much control over how our numbers are printed out. We can use format in order to change that. So I could type format short G to make sure that they always end up looking like this. But this is essentially how things were printed out. For the flow of insert some data with a density of insert some data and a velocity of insert some data, the pressure drop across the enlargement as a function of the diameter ratio is, and then I printed out a table. I'm going to do the same thing, but using fprintf. So I'm going to print out this same text using fprintf. So I'm going to comment that out just so we don't have a bunch of printing out. And let's repeat it with fprintf. So here is where I'll write on my notes over on the side here. Or for you guys, it's the top. For me, it's the side. So let's print out the first line using fprintf. So fprintf and disp, like I mentioned, it's very similar in the sense that we're going to combine some text with some data. With display, or the disp function, we created a new array. With fprintf, it looks like this. We're still going to have our string that contains the text, for a flow of, And then I'm going to insert some data. So I'm just going to indicate with underscore right now with a density of insert some data, kilogram per meter cubed, and A. To insert data with fprintf, we are going to do something like this. We are going to put a % sign followed by what's called our conversion character. So in here, I'm going to put % signs in my code. And then I need to indicate what kind of data I'm going to insert. So we have a couple options. %s indicates we want to insert some text. %f indicates we want to insert some numbers. There are other ones. There's %i or d for integers. There's %e for scientific notation, %g that's not a g, for choosing between f and e. So there's a bunch of options, but really these two, s and f, this is your wheelhouse. This is the ones that we are going to focus on. So for this first space here, I want to enter in some text. So for a flow of insert some text with a density of, and then I want to insert a number. So I use %f. And then I need to indicate where that data is stored. So the data that stores the text is located in the variable called type. That's what we called it on Monday. And then the variable that stores this number here is row. So for fprintf, it's going to print out for a flow of insert some data with a density of insert some data, kilograms per meter cubed, and A. The data it's going to insert here corresponds to this first variable. The data it inserts here is going to correspond to the second variable. So now when I run my code, it prints out for a flow of gasoline with a density of 735 kilograms meters per cube and A. Notice my cursor is right here. It's right at the end of A because I didn't put a \n. So this n indicates that once you're done typing A, press enter and go to the next line. So now when I rerun it, we can see that my cursor ends up down here versus right here. I also want to point out that when you use %f, the default is to print out 6 digits past the decimal point. We can change that, and I will get to that later in a minute. Okay, so I've printed out my first line. Let's go ahead and print out my second line. So fprintf, velocity of, I want to insert some data. So I'm going to use that data's number, %f, meters per second, the pressure drop across the enlargement. Sorry, I had to sneeze. There we go, across the enlargement. And then new line. The data I want to insert here at this %f is in the variable called v. So now it prints out for a flow of gasoline with a density of this and a velocity of insert number, the pressure drop across the enlargement. So I've printed out 2 lines. Let's print out my last line. fprintf as a function of the diameter ratio is new line, then I'm done. I didn't insert any data in here, so I don't need any variables. So there we go. I have printed out my 3 lines. I've inserted data here, here, and here. With display, I need to do this in 3 lines of code. So display, it looked like here. I need to do that in 3 lines of code in order to insert my new lines. The nice thing about fprintf is I don't need to do it on more than 1 line. I could technically do this all in 1 line. It would look like this. I can just combine all of this into one nice big string and then print out type, row, and v. Where this will do the same thing. For a flow of insert some data with the density of insert some data and a insert new line, velocity of insert some data, meters per second, the pressure drop across the enlargement, insert a new line as a function of diameter ratio is new line. Where type is inserted here row is inserted with my second one, and then V is inserted with my third one. So it prints out the same thing. So here's my 3 lines of code. Here's my 1 line of code. So, Benny, is that what you were talking about? Combining it into 1 line? I think that's what you're talking about. JR, do the variables need to be defined in the same file? Yes, if you want it to be self-contained. Your variables, so here my variables are located in line 5. Anytime you're using a variable, they should be defined somewhere in your code, somewhere in your program. So Benny, we can't do that with disp because disp doesn't allow us to use \n in our string. Well, let me try. Let me try. For a flow of type with a density of num2 string row kg meters cubed and a let's try this. If I remember correctly from Monday. Yeah, so disp does not interpret \n as a new line for some odd obscure reason. It just interprets it as a \" character and an n character, whereas fprintf sees \n as the new line character. So display is kind of one of those simple functions that MATLAB has to allow you to do some basic display that's easy to use. fprintf gives us ultimate control over everything that's printed out. So fprintf, it's similar. It's essentially a rollover from the C language, where it gives us explicit control over every single character, all the white space, everything that's printed out. That's the best answer I have for you, Benny, because display is like a hack. Okay. So, like I said, when we write our code like this, okay, so for display, you can have it all on the same line, but then, so yes, so you could technically print it all on 1 line, like you don't need these \n's in there, but your command window will not word wrap. Your command window won't word wrap. So that's why we put in those \n's, just to make it more readable in our command window. Okay, so when we print out our numbers like this using %f, the default is to print out with 6 digits past the decimal point. fprintf gives us some additional options that we can insert between the % and the f that gives us more control over how we want our numbers printed out. So for fprintf, we have our %, and then we have 2 optional values next to our conversion character. So this would be our F or our S. So I'll just put it as F here. Where this one that goes after the period is one you'll use a lot. This tells us how many digits past the decimal point to print out. So it's a number. So if I want to print out this number here, row, with 3 digits past the decimal point, I would say 0.3. So this indicates that this number, whatever it is stored in row, is going to be printed out with 3 digits past the decimal point every single time. If I wanted V to be printed out with 5 digits past the decimal point, I could say 0.5. So now the default is 6, but I've manually changed it to print out 3 here and to print out 5 here. Let's say I didn't want that. Let's say I wanted 2 and 1. I would just go change those numbers, print out with 2 and 1. So now it's 2 and now it's 1. I can also print out 0 digits past the decimal point. So if you're expecting an integer, you can use %d or %i. Both of those are for integers. But I like to use this instead, just because it's cleaner, it's more explicit, and it's a little bit more error proof than using %i or %d. So now it prints out with 0 digits past the decimal point. So we can have control over how many digits past the decimal point we want to print out. I'll put it as 2 right now. This second option here is called our field width. It's also a number. It goes in front of the decimal or in front of the period. And it identifies how much space we want to use to print out the number. So for this one here, this one is printed out with 1, 2, 3, 4, 5, 6, 7 spaces. So 1, 2, 3, 4, 5, 6, 7. This one here takes up 1, 2, 3, 4, 5, 6. This one here takes up 3 spaces. So by default, the number will take up as many spaces as it needs. However, if we want it to be more than that, I can change the number to say, let's say I want it to take up 10 spaces. And this one to take up 5 spaces. So now it prints out just more space to print out the number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it takes up 10 spaces here. 6 of them are used to print out a number, and then there's 4 blank spaces. And our number is always going to be right justified. For this 5 here, it takes up 1, 2, 3, 4, 5, 6, or 5 spaces. 4 of them are used to print out a number. 1 is used to print out a blank space. A lot of times we don't use the field width when we're printing out text and data together. But I wanted to demonstrate that. But most of the time, we're going to use this option where we use a period and then a number to indicate how many digits past the decimal point we want to print out. Okay, so I have printed out 1, 2, 3. Oh no, I lost my table. Okay, so the next thing I want to print out is this table. So I can print off my first and second lines. Those are just text. So I'm just going to say fprintf, diameter, pressure drop, \n. And then I'll just print out my second line already, ratio, pascals. So note here I could do this in 1 line, whereas with disp I needed to do it in 2 lines. You can do it in 2 lines, not that big of a deal, but that's an option with fprintf. Okay, now, printing out tables with fprintf is a little bit more complicated. It's not overly complicated, it's just remembering how to do it. With display, all we did was we just combined our data into an array, where the first column was our first set of data, the second column was our second set of data. For fprintf, what we're going to do is we type fprintf, and then we have our string. And in this string, we want to identify how we want each row to appear. So if I look at my table here, I want this first number to be a number, followed by a second number. So that's going to be %f, followed by a %f. Then we're going to use our additional options to space things and make sure things line up and are consistent. So let me give more space here. So I want a number followed by a number. This first number, you can see here, I really only need 1 digit past the decimal point, so I'm going to do 1 digit. This second number, it's variable shown here because this is what display has. Display is automatically going to choose how many digits past the decimal point to display. We don't have control over that. However, with fprintf, I can choose. Do I want it to be always 2 digits, 3 digits, 4 digits, 5 digits? What do I want it to be? I'm going to choose 3 digits because I have control over it. 3. If I want more, I'll change it. If I don't, I can change it too. And then I want my width. Width. There's a D in there that we don't pronounce. Width. So for a table, you'll play around with it. If you want a value to start with, just start with 10. Okay, so I want to print out a number, taking up 10 spaces, 1 digit past the decimal point, placed next to a number, also taking up 10 spaces, 3 digits past the decimal point. Okay, so I'll type that in. 10.1f, 10.3f. And then I want to follow that by a new line, saying I want my next set of numbers to be on the line below. Okay, so first things first, when we're printing out a table with fprintf, identify what you want each row to look like. That's the first thing. For here, I'm indicating I want a number placed next to a number. That's it. Two columns. Then we need to create an array that contains all of the data. For display, we wanted our data to be in columns. For some odd reason, with fprintf, we want our data to be in rows. So whatever you want your first column to be, that should be your first row. Whatever you want your second column to be, that should be your second row, third column, third row, fourth column, fourth row, etc. So for this table, I want R to be my first row, or my first column. So that's gonna be a row, followed by del P. So if I type this out, or if I identified what this array looks like, it looks like this, where this first row are my R values, this second row are my del P values. So what MATLAB is gonna do is it's going to take this first number, print it out according to this. Take the second number, going down a column, print it out according to this. Then it's gonna print out a new line. And that's gonna keep going column by column, repeating this structure until all of the numbers are done. Okay. Run it. This is what it looks like. So once again, this is a width of 10. So this 0.9 takes up 10 spaces. Let's say I don't want it to be 10 spaces. Let's say I want it to be 8 spaces. Change the 8. Run. So now instead of it taking up this much space, it only takes up this much space. Yeah, this is pretty good. It's not aligned exactly the way I want. Let's move diameter over 2 spaces. Run that, see what it looks like. Okay, we're getting better. I want these numbers to be shifted over, so I'm going to change this 10 to 15. So we can see now instead of it taking 10 spaces, it takes up 15. That's a good distance, I think. So let's move pressure drop over. Pressure drop moves over to, PA moves over to, PA needs to move over more. So you just play around with things until they line up the way you want them. So when we did DISP, we didn't have control over how the numbers were printed out. It was whatever MATLAB decided the default is going to be. Here's the default, using format short G. With fprintf, we have explicit control over how we want our numbers to be printed out in a table. So just to review this process, because it's a lot. We type out how we want each row to look like. For this table, I want a number to be replaced, or to place next to a number. Yep. Daniel, I'll get there. So here's a number placed next to a number. This first number I want to be printed out with 1 digit past the decimal point. The second number I want to be printed out with 3 digits past the decimal point. The first number I want a width of 8, so I wanted to take up 8 spaces. And the second one I wanted to take up 15. And then \n. So each column or each row is printed out with this format. And then the data is going to be a new array where the first row is my column. My second row is my second column. So so here, let me show what this is again. Run. So notice this row became this column. This row became this column. And just play around with it. If you switch that around and it looked like this, it'll look funny to you. So be like, ooh, that's not the way I wanted it. Okay, let's try and transpose those, see if it fixes it. But for display, the disp function, we want our data to be in columns. For fprintf, we want our data to be in rows. That's just the way it is. Okay, we'll go over another example later as well. So anything you would do with disp, you can do with fprintf. Fprintf, though, is much more variable. You have a lot of control over everything. \n is explicitly used to insert a new line. We have control over how we want our values printed out, how we want our numbers to be printed out, how many digits past the decimal point, how much space do we want them to take up. And there are options, like there's a lot here. There's a lot that fprintf gives us control over. Unfortunately, when we have control over everything, that means we need to be aware of everything. So just try something, see how it prints out, change it, see how it prints out, change it, see how it prints out, and keep going until it prints out the way you want it to print out. Okay. Let's get to another example. Let's talk about load and save. So here's another problem that I'm going to use in order to go over load and save. And then we'll do another example for printing out data using disp and fprintf. Okay, so here it says import the data from the silver.dat file using the load function. So it says import the data. Import indicates that you should use the load function. Also, it telling you to use the load function is an indicator that you're going to use the load function. So the load function, we just type the word load, open close parentheses because it's function. And then inside of our parentheses, we're going to insert the name of our file in quotes. So it tells me import the data from the silver.dat file. So silver.dat. There we go. That's load. That's it. Keep in mind, the silver.dat function needs to exist, and it needs to be in your current folder. So here in my current folder, I have a file named silver.dat. If that file was not there, MATLAB would tell me file not found or something like that. It would give me an error. Okay, so there we go. Load silver.dat. We can also say load silver.dat. So load is one of those special functions that MATLAB has to confuse everything, but we don't need the parentheses. We could just say load space silver.dat. Note silver.dat shows up in purple, which means it's read correctly. Flora, that's a good question. I can show you guys how to do that at the end of class, specifically for the text file for homework 5. So if I do not remember, remind me when class ends. It's really quick. I can show you guys how to get that data. Okay, so I'm gonna get rid of that one. Here we go, load silver.dat. When I run it, the data from silver.dat, so if I open silver.dat, it looks like this. It's in scientific notation. The data from this file is imported into the workspace. It's gonna be in a new variable that contains the same numbers. So here's my same numbers. Notice the variable that it uses is called silver. That's the name of my file. So when you load in data from a file, that data needs to be square. It needs to be valid, a matrix, and it's gonna automatically create a new variable with the same file name. So keep in mind, when we're talking about load, we're talking about .dat files or data files, .txt files or text files, and then also .mat files, which are inherent MATLAB files. So .dat and txt, these are text readable, which means we can open them up in Notepad, in TextEdit. You can see we can open them up in MATLAB. The editor is just a text editor. So there's the other way to use load. If we want to have control over over the way we want that variable to be named, I could say a equals load silver.dat. So here's another thing we can do. So now a contains the data versus silver containing the data. Okay, so we don't have to use this as our variable name. We can have control over what that variable is going to be called. So these are one of our 3 options. But really, it's just load and then name of the file. keep making, name of the file needs to be in single quotes, unless it's this first option. Okay, so now, this data. When we import data, the file needs to only contain numbers, so it's not going to have text. There's no headers on this data. So it's important that we understand what our files contain. For this file, this document here tells me that column 1 contains the temperature in Kelvin, and column 2 contains the specific heat for silver in calories per mole Kelvin. Okay, so I need to know what this file contains in order for it to be meaningful, which is fine. It just requires some additional description. But our files contain only numbers for the purposes of our class right now. So I'm going to do some processing on this. I'm going to copy it over. Wrong one. Nope, right one. Okay. So what I did with this data is the first column, so all rows first column is my temperature. All rows second column is my specific heat. So I've just separated my columns out so I can work with them separately. You don't have to do that, but that's my decision as a programmer, how I wanted to deal with it. And then here I've just converted my temperature from Kelvin to degrees Celsius. And then here I've converted my specific heat from calories per mole Kelvin to joules per mole Kelvin. And then here I've converted it from joules per mole Kelvin to joules per gram Kelvin. So I just did some processing in my data. In this example, just unit conversion. So I've converted my data to different units. Now it says to save my converted results into a file called silverconverted.dat. So import means use the load function. Save means use the save function. So import is load, save is save. So load and save look very similar. Save also, we can type save and then space, and then we just type the name of the file that we want to create. So silverconverted.dat. I could also do save silverconverted.dat. Also valid. But the difference is load, we just need the file name. For load, if we do not have a equals, load is going to load the data into a variable the same name as the file. A is just the purpose of having control over what that variable is. So if there is no A, then it creates a variable same name as the file. If there is an A, it's just going to create the variable to store the result. So if I didn't have this, A would store my results instead of silver. So it's just really what you want your variable to be called. Are you okay with your variable being the same name as the file, or do you want to have control over that? And they're just different options. Once again, a lot of that is programming knowledge, programming design. Sometimes you know what the file name is going to be called. Sometimes the file name is going to be stored in a different variable. So it's just design decisions as the programmer. Okay, so let's get back to save. Save, you need the name of the file that you're going to create. You also need a variable that contains the results that you're going to save. Okay, so I have originally, silver had two columns, temperature and specific heat. So I did conversions, and I'm going to recombine those into a variable called results. It doesn't matter, where my temperature is now in degrees Celsius as the first column, and specific heat in joules per gram Kelvin in the second column. So I'm creating a new variable that takes my results and combines them into one. So when I say save, I name the file, and then I also identify what I want my variable, what variable to save as well. So here it's going to save, it's going to create a file called silverconverted.dat, and it's going to save the data in results to that file. Down here, it looks very similar. There's just a comma and things are in quotes. So both of these are the same. They're both valid. Once again, with the save function, we're talking about .dat files, .txt files, and .mat files. If I was saving it in a .mat file, I'm done. I don't need to change anything. For a .txt and a .dat file, I need to add one additional option, and that's /ASCII, which this indicates that I want to ensure that my results are saved in a text readable format according to what's called the ASCII, according to the ASCII table, or the ASCII standard. So here it says save, create this file, save the results in text readable format. Same thing here. So when I press run, now I have this second file that shows up in my workspace or in my current folder called silverconverted.dat, and it contains my results. So it contains the same thing that's in my results file. It just saves them in text readable ASCII format. Scientific notation is what the ASCII default is. And I don't know how to change it. I don't. It's just the way it is. Okay. If we were doing a .mat file, we do not need the ASCII option. So let me go ahead and take that off, and let me show you what happens if we leave it off and we're saving a .dat. So if you leave that off and you save a .dat or a .txt file, what it's going to do is it doesn't, by default, convert that file into the ASCII format. It encodes it the way that MATLAB encodes mat files, and it looks like this. It's just a bunch of gobbledygook, a bunch of garbage. Because a .mat file is a special file that is it's proprietary coding by MATLAB. It can only be opened in MATLAB. So it can't be opened as, it's not text readable. So whenever you're saving .dat files or .txt files, you need that ASCII option. And once again, either of these will work. You do not need both. And there you go. You did it. You saved your results. So load and save and input, those are both fairly straightforward. Load, name of file. We're talking about .dat, .txt, .mat files. Save, you need save function, the name of your file, the variable that stores the results you want to save, and your ASCII option. There are other input-output functions that you can use with MATLAB that allow you to work with spreadsheets. Those are beyond the scope of this course, though. But if you want to do that and import data from a spreadsheet or write data to a spreadsheet, just Google it. You can talk to me about it in office hours. I would be happy to let you know. But there are more useful functions than the load and save function. But this is the scope of this course. We're going to talk about load and save, which is working with data files, text files, and mat files. Okay, let's load, save. Let's do a couple more display and fprintf examples. So let's say that I want to print out this data. So JR, yes. So silver.dat, whatever file you're reading in, .txt file, .dat file, it needs to be a square set of numbers. It needs to be directly imported into a matrix that's fully square. That's a really good question. Yes. So a lot of times when you're loading in files, it contains columns of data, like, rectangular. Square meaning that it needs to be rectangular. Rectangular is fine. So it will not fill in missing locations with zeros, at least not the last time I checked. MATLAB may have done some fancy update in the 2020B version or 2021A version, which is going to be released in a couple months. But it needs to be rectangular. It needs to be directly portable into a matrix. It will not fill empty spaces with zeros. I mean, you can try it. Like I said, maybe MATLAB did some wonky things recently, but you can always try it. But that's to my knowledge, you cannot import data that's not rectangular. Okay. Good questions. Good questions. I like you guys' questions. Ask away. So let's do another example with display and fprintf to print out my results in a table. So with disp, it's relatively straightforward. I have 2 lines of header data, so I can just display those. Temperature, specific heat. It will automatically insert my new line. Then I can line up my my units. So degrees Celsius, right under the PERA, and then underneath the E, joules per gram Kelvin. And then to print out my data, my numbers, remember I'm going to create a new variable that contains my temperature in the first column and my specific heat in the second column. Okay, so these are columns because I'm using disp. So it's going to print out exactly the way it's stored. So disp, new array, my temperature, OC, and then SH, JP, GK. Essentially, I'm printing out results. So there we go. It's printed out. And now I can see the way it's printed out. I can go ahead and align. See what that looks like? Hey, not too bad. Move it over one more. And I can see the way they're lined up for the most part. That's using disp. If I wanted to print out with fprintf, same idea. These two things essentially stay the same. I just need to insert my new line. So fprintf, temperature, space, specific heat, new line, OC, joules per gram Kelvin, new line. You can do that all in one line of code. Sometimes I like to do it in more than one line of code just because then I can manually see in my program where everything lines up. Like I can space it as I need to and line things up in printing out here versus having in one line you can't see how it's going to line up. Okay, so that's my header files, or my header. Now to print out my data, so backslash, so it's the one right underneath backspace, right above enter, over there. It's not forward slash. Okay, so remember, printing out our data as a table using fprintf. I'm going to identify how do I want each line to be printed out. So I want a number placed next to a number. So I have %f next to %f, and then new line. My first number, 2 digits past the decimal point, that's great, print it out. My second number, it's all over the place with disp. Here it's 6, here it's 5, here it's 4. I have explicit control over that with fprintf. I'm just going to choose a middle one and say I want all of them to have 5 digits printed out past the decimal place. And then how much space do I want them to take up? So, I don't know. By default, if I do 2 digits past the decimal point, it takes up 1, 2, 3, 4, 5, 6, 7, 8, 7. So I need at least 7. So let's say 10. And then how much space do I want this number to take up? I don't know. Let's go with 15. Let's just throw a number out there as a starting point. Okay. So each row I want to be printed out like this. Then my data is going to be in rows. So temperature is my first row, and then specific heat is my second row. I think it rounds. I'm pretty sure it rounds. Oh, let's see. Let's see what happens. So this first number, let's make it big. This first number with display, it printed out 6 digits. With fprintf, it printed out 5. And it truncated here. For the second number, same thing, 6 digits with disp. Here, it printed out 5, it does round. You can't change how it rounds unless you explicitly use the round function. What do you mean? Like, if you always want it to floor? So you can always do like floor and floor all your numbers if you want, or ceiling, or round. It's up to you. So now with fprintf, they all have 5 digits past the decimal point. Here it takes up 15 spaces. Here it takes up 10. Let's say I don't like that. Let's say 15 is too far. Let's make it 12. Run it, see what happens. Okay, now they're closer together. I want to align my header. So once again, just manually change it. A little too far. That's a little better. Specific heat, okay. So I like specific heat the way it is, but I want more space here. So I'll go back to 13. Let's do 13. Let's move it over 1. Okay, there we go. That's a little better. Maybe I don't like 5 digits. Maybe I like 6 digits past the decimal point. Just change it, modify it, see what you like. There we go. So with disp, we don't have control over how the numbers are printed out. You can see it's all over the place. They're nicely aligned here, but it's not quite aligned here. Whereas fprintf, everything's nicely aligned. Another thing we can do with fprintf that we can't do with disp as easily is we can print out each set of data using text surrounding it. So let's say I want to print out this line for every single set of data. Once again, it's essentially printing out a table where I want each row to look like this. For T equals percent 0.2 degrees Celsius, specific heat of silver equals percent 0.4 F joules per gram Kelvin. New line. Once again, the data I want is in results transposed. Row 1 is temperature, row 2 is specific heat. Whoop. Forgot my F. There we go. So now for each set of data, it prints out the full text. So AP Cruzy, if they were originally not transposed, it would just look funny. So here it just looks funny. It's not consistent. It's not the way you expect it to be. So you would just change it. Say like, oh, I forgot to transpose it. So you would just change it. Here I can also use the width as well. Let's say I want these temperature values to line up. So I want each of them to be a default of 6. Nope, 7. There we go. Now these ones are nicely aligned. So this is something you can do with disp. You would just need a loop in order to do it. It's not as easy to do it with disp, whereas fprintf, we can combine repeated text and numbers easily that you can't easily do with disp. Okay, those are 2 examples using fprintf and disp. I will create a video going through another example. So here's another example problem. I will create a video going through how to put that together as more examples later today. I will post it on UB Learns. Other than that, we are done for today. I want to go show you guys how to download the data from UB Learns. So here's UB Learns. Courses. So for homework 6, homework 5, you're going to have to download this file. For some obscure reason, you cannot just download it. UB Learns is weird like that. So it looks like this. So you just copy, paste it into a new text file in MATLAB, right click, save it as tv.txt, and it will nicely show up in your command or your current folder as a .txt file. So just copy and paste it, create a new file in MATLAB, save it as tv.txt. Okay, it needs to have that name because that's the file that I'm going to use. Okay, Flora, hopefully that answers your question. Any other final questions? So for the save function, you need 3 pieces of information, or 4. You need the name of the function, which is save. This is the name of the file. This is the name of the variable that contains all of the data you want to save. And then this is to indicate that you are saving a text-readable file, such as DAT or .txt. You can also do it this way. Save function, name of the file, name of the variable that contains all of your results, and then the ASCII, which indicates you want it to be text-readable. Does that make sense, Michael? Is there anything else you wanted me to review on that? Yep. Okay. Any final questions before we head out? Like I said, I will create a video with one more example. It'll be however long it needs to be, that I'll post on UB Learns, that you guys can use as a reference. Okay. With that, if there's nothing else, I will see all y'all next week. It's getting real. It's getting real. Real programming. It's a little more difficult. We're getting there. You can do it, though. You can do it. Ah! Yes, it's supposed to say week 5. I was doing so good. So good. Okay. Have a good week.